All right, folks, this should be hopefully a nice, quick and easy kind of presentation. And then most of what you'll pick up for this lesson will be in the practice that you do later. But we're going to look at combining logic gates. We've already talked about logic gates, but now we're going to look at combining many of them. So as a quick review, you can see how the logic gates laid out here. The main reason that I'm going to present this as a reminder is because I want you to take a look at and pay attention to the symbols that we've got here. So the AND, NAND, OR, NOR, XOR, and XNOR gates. So take a look at those, kind of notice the symbol. Notice that the main difference between the N version of a gate and the original is just this little circle out front. But yeah, we can use these symbols to draw complex circuits, complex logic circuits, and all of that. So what do you do for that? Well, you just, draw gates. So let's say we want to start by having an AND gate here. So it's going to have two inputs. And pardon the sketching here, it's going to end up being a little messy, but you'll get the idea. And then we'll have, say, an OR, or let's make it a NOR gate here. And pick another one down here. Let's do an XOR. And then you have all your inputs. And then your output can just connect up to the input on another gate. And then this can point out to whatever you want to connect to. So let's throw in some values. Let's say this is a 1, this is a 1, this is a 0, and this is a 1. So then if we look at this, we'd expect 1, 1 into an AND gate. That would give us a 1 out of that AND gate. A 1, 0 into a XOR gate would give us a 1 out. So we have 1 and 1 going into this NOR gate, which means we'd have a 0 out. And so you can see how you can combine a lot of these. Maybe you've got a setup where you'll have an AND gate, and then it connects up with just declaring a value here. So there is no other gate here, and then these both go into, say, another XOR gate here. So you can have all sorts of combinations. They can get really complex, but that's the idea, is you just sketch them, and then you draw wires to connect things. You can also have a single output connect to multiple inputs. So this, right here, you see that this output on the AND gate goes to two different things. That means whatever this AND gate gives out, it goes into these two. Excuse me. You can't have, though, multiple inputs on these types of logic circuits, these logic gates. They only take two inputs. Now, it's a little strange, but in theory, you can have both outputs. You can have two outputs go to two inputs on another gate, but that typically doesn't make sense. You'd usually use other things, but just going completeness, this technically can work. Okay, so let's talk about how to decipher or understand logic circuits. So basically what you do is you just start with inputs and you start working your way through and figuring out what's going on. And this is just a screenshot from the web app that I'll have you practice with later, and the way that they show whether something's active or not is by, you can see here, coloring in the wire. You could also label, ones and zeros. Like, for example, this AND gate only has 1 coming in, so it'd be a 0 out, so we wouldn't color in this top wire here. Then we have this XOR gate, which means it's looking for only 1 input. It's got exactly 1 input, so it's going to have a 1 going out, which, like I said, in the web app will look like shading this in. Now we've got an OR gate, which looks for one input or two inputs. It's got one input, so we're good. So we'll shade that in. And then this bottom one is a NAND gate, so it's looking for anything but both inputs. So we've got one input, so we are good to go here. So we'll shade that in. And now we've done that first layer, we move on to the next one. This OR gate looks for one or the other. And so it does have one input, so I'm going to shade that in. And then we've got this XNOR, which means it's looking for anything but exactly one input. So we've got two inputs, that's not exactly one input. So we'll shade that in here. And then lastly, we've got our AND gate. So I took this off for a reason that will be clear in a second, but this last one should also be shaded in, and that means we do get signal to the light, so we'd expect it to light up. And if you see on the overlay, we do in fact have that. What I want to highlight with this is just that you don't have to color or shade these in. You can just draw or label a thing. So this would then be a 1, this would be a 1, this would be a 1, and just knowing ones versus zeros. But that's the idea here. What you're going to go work on next is just practicing creating some of your own and thinking what you'd expect to see.